Good afternoon to one and all. I welcome everyone for day 3 of Faculty Development Program. I now request our beloved HOD sir to speak few words on today's event.
Thank you, Karthik. Uh, Advancement of civil engineering is a must for everybody, who are concerned with this. So, good afternoon, everybody. Good afternoon, Dr. Manjunath.
Good
Uh,
afternoon, sir. Good afternoon.
Good afternoon, sir. I don't know. You remember me? I don't know. I was with BMS. I used to move with RVR and Raghunath for a coffee and all. I met you for 3 or 4 times there.
Oh, no, definitely. I was always coming to BMS College so many times.
Yeah. I don't know. I'm Uday Sima. I was working there. Now I'm retired and I have taken up professor and head here, Netly Institute of Technology.
If I see you for our photo, I will be able to find out.
Yeah. Okay. Thank you. So anyway, I welcome you to this, this series of FDP. So going on with respect to the advancement of civil engineering, I welcome you and I know you and I know you are a very good orator because I have seen you, I have heard you. Many times, conducted a program at BMS College, so we used to come and hear you. So I welcome you, and definitely the topic what has been chosen with respect to the concrete will be helpful for our the students and the faculty members, and the students and the faculty members. I think we have to make use of the very well known person in this area, Dr. Manjunath. Okay, so I welcome you, sir. I think the next, of course, the platform is yours. So I over to Karthik.
Thank you,
Thank
sir.
you, sir. Thank you. Thank you.
I now request my coordinator Pratibha Madam to give a brief introduction on today's speaker.
Uh, I take this opportunity to give a brief introduction about today's speaker, Dr. L.R. Manjunath, Zonal Head and Associate Vice President, JSW Cement Limited. He received his BE in Civil Engineering from UVCE Bangalore and MBA from International Institute of Advanced Marketing, Mumbai. He has postgraduate program in concrete technology in 2019, future fit leadership program from Indian School of Business in 2018, and PhD in management from Bharatiyar University Coimbatore in 2018, and has total experience of 27 years in construction, building materials, techno marketing, applications development, new products development, branding, business development, sales and product training, mentoring and advising in the construction industry, corporate and industry service sector and startups. He is presently working as Associate Vice President Marketing at JSW Cement Limited and advises on project research work in civil engineering and management for research scholars from reputed institutions. He is constantly pursuing his research interest in green building materials, concrete admixtures, special concrete, alternatives to river sand, new construction technologies and products, and training on skill development for civil engineers and advisor on career development for young engineers and management students. He has research experience of 12 years and has published over 27 research papers in national and international journals and in 40 conferences in his research field and delivered more than 300 guest and expert lectures across the country. He was the chairman of Delegate Mobilization Committee held from 19th to 22nd September 2018 at Bengaluru. Recently, he has attended the SEWC 2019 World Conference as the chairman of Indian Delegation representing Association of Consulting Engineers for the Structural Engineers World Conference in 2019 held at Istanbul, Turkey. He is a life member of ICI, INSTRUCT, IOB, ISTD, ACCE, and American Concrete Institute. He was the ex-honorary secretary and vice chairman of Indian Concrete Institute, Bangalore. It is a great pleasure to have you here with us, sir. Welcome you. Over to you.
Thank you, Pratibha, for that wonderful introduction. Good afternoon. I'm sorry there was a delay from my end. Working in corporate, suddenly get a call from our CEO that he wants to have a Zoom meeting. So because of the Zoom, that now we cannot escape. So we have to attend that. It lasted a few minutes and could conclude the meeting and join you immediately. I would like to share my presentation today. Is it visible?
Yes,
Is
sir.
is it visible?
Yes, sir, it is visible.
Okay. Yeah. This my today presentation is special concretes durability and sustainability. My dear students and friends, the staff and teaching faculty of IT Institute of Technology. It's a great occasion that the faculty development program is being organized by the IT Institute of Technology. I used to visit ATRIA long ago along with Mr. Mohan Rao. We used to do a lot of training for the young civil engineering students who are graduated and are looking for job opportunities under the banner of Builders Association. I used to come weekly. About 2 months we used to do the training and provide employment opportunity for all the students. Today subject is very relevant, special concretes for durability and sustainability. As we all know, I would like to give a brief introduction about my company, JSW Group, one of the largest business house in India. We are into steel, we are into energy manufacturing. Energy means thermal energy, hydroelectric energy, also wind energy. We are into cement manufacturing, from where I belong. 2009, JSW started its journey cement manufacturing. So we are having now close to 14 million tons. And JSW paints also recently have started. Background for this presentation is that we all know cement is the material we use for making concrete. The Roman period, they started using volcanic ash to make the concrete. At that time, it was not reinforced concrete. We know Roman Colosseum and other structures, aqueducts and all. They were all built by using the volcanic ash and mix it with straw, horsehair. They used to use animal blood for making as an admixture. So those structures are still there. So 1824, Joseph Aspidin, he was a bricklayer in Britain, in a village called Portland. So he manufactured cement by burning limestone. He developed a clinker. So the journey of cement manufacturing started from that day. In 1828, first concrete was made using the cement. So somewhere in 1866, the rotary kilns were invented. Rotary kilns to manufacture cement in bulk quantity, huge quantity. Today, close to 4.3 billion tons of cement is being produced in all over the world. We are producing about close to 13 to 14 billion cubic meter of concrete. So, cement production is not an eco-friendly activity. To make 1 ton of cement, we need to consume 1.5 tons of limestone. Coal, we have to consume 0.2 to 0.25. Okay, so we require a lot of water during manufacturing of cement. Then we require a lot of limestone. We go to pollute water, pollute air. So globally, about 5 to 6% of the emissions are happening through cement manufacturing. India is not falling behind. India is the second largest producer of cement in the world. We produce about 400 million tons and installed capacity about 550 million tons. Very soon, we are going to be about 1,000 million tons capacity because China produces 2,000 million tons of cement every year. So the population of 1.3 billions can consume so much of cement. Already we have crossed 1.35 and we are going to be the most populous country in the world. It's likely to be about 1.4 to 1.5 billion population reaching 2050. So with all that, we construct metros, we construct highways, we construct tunnels, we construct ports, housing projects. Everywhere we're using cement. So with that, what's happening? The urban heat island effect is happening because we're creating more and more concrete jungles. Today, Bangalore area is about 1,000 square kilometer. City like Bangalore, 1,000 square kilometer. You may not find a forest of 1,000 square kilometer nearby vicinity of Bangalore. So that is the development happening with the continuous development, and we are going to raise the temperatures. Temperatures in the urban area it will rising, and ocean temperatures are rising. With the ocean temperature rising, there is a temperature gradient between two oceans, Pacific Ocean and Indian Ocean. Huge water of getting huge mass of water is getting lifted, and we are now getting sudden rains, heavy rainfall happening within one span of 1 hour, 2 hours. So flooding is happening. So these are all the harmful effects of natural degradation. So, friends, my dear students, sustainability. We want to make the construction sustainable because we cannot stop the construction. So, construction as a industry consumes about 40% of the world's energy. Okay, and also 30% of the greenhouse gases emission. Imagine, friends, 30% of the greenhouse gases being emitted by construction industry alone. Then 10% of the world's fine dust. The dust, whenever we do construction, we are seeing now Bangalore going a lot of changes. Bangalore is getting converted into smart city. Roads have been dug up continuously, and dust is coming. So we are doing a lot of site mix concrete also, because we are having a lot of individual houses being constructed in cities, not only in cities, all the areas. So we bring sand, we bring cement, we bring aggregates and dump it on the roads and start constructing. With that, you are going to emit a lot of dust. But it's all banned in other countries. So site mix concrete is completely banned. So with that, what I'm going to tell, the construction activity is not sustainable. To make it sustainable, we have a challenge because we cannot stop construction. So it has to happen continuously to the requirement of the 1.4 billion populations of India, and continuously construct and also reduce the carbon footprint. India is the third largest emitter of carbon dioxide. 6.6% of the global carbon dioxide emissions are emitted by India. So going forward, we need alternative materials. Since we cannot stop the construction going, we need to develop alternative materials, alternative concrete, special concrete, so it can bring down the carbon footprint. Your regular concrete cannot reduce the carbon footprint because we continuously consume OPC cement. Each ton of OPC cement production, 800 kgs to 1000 kgs of carbon dioxide is emitted. So being a civil engineer, you are going to be graduates now. The moment you graduate, your challenge is to work in the construction field. And when you take up the construction, your duty is to reduce the carbon footprint, whatever construction. You may be a contractor, build a small house, build an apartment, build a metro, build a highway. So you have to reduce the carbon footprint. How we can reduce the carbon footprint? Okay, by having sustainable approach. Sustainable approach is nothing but.
Excuse me, sir. Sorry for the interruption. Sir, the slides are not changing.
Oh, no, it's not changing.
No, sir.
Oh my God. 1 second. Now?
Yes, now it is sharing. Sir, can you slide share, like full slide? Slide show.
Full slide share is not happening. There's maybe a problem.
Okay, okay, sir. Now the slides are changing.
I'll go like this way only. It's okay?
Yes, sir. Yes, sir. No problem.
I may have to reduce this. This is okay, no?
Yes, sir. Yes, sir.
Okay. So, concrete production. We know concrete production. Concrete involves usage of cement, aggregates, water, chemical admixtures. And earlier, concrete was only a mixture of 4 to 5 ingredients. But today, concrete is a mixture of admixtures. So we have many alternatives in terms of cement, we are using GGBS, we are using alkofine, we are using fly ash, we are using metakaolin, cementitious materials. We are using ultrafine GGBS. In terms of aggregates, we are using natural aggregates, we are using artificial aggregates, we are also using CND waste. In terms of sand, we are using slag sand, we are using M sand, we are using copper slag sand. So admixtures, earlier we were using naphthalene based admixtures. Now we have migrated to PC based admixtures. So in admixture itself, there are more than 100 categories, which will help to modify the properties of concrete. So we want to make concrete should be sustainable, durable, eco-friendly. That optimization of the material is very important. You have to follow IS 10269, the guidelines of concrete mixed design 2019. New the new mixed design code book has come. As per that, they are allowing the use of GGBS in the mixes, allowing the use of fly ash in the mixes. So using recycled aggregates is a must, as I already told you. Aggregates are available now, slag aggregates, then fly ash aggregates, then copper slag aggregates, many types of aggregates, CND waste is available. Using innovations in the materials and process is a must. Why innovation is important? As you innovate, so your dependency on the natural aggregates will come down. We try to use alternative materials, okay, lightweight concrete, structural lightweight concrete, geopolymer concretes that I'm going to talk about. So improvement, optimization of structures, going for composite structures, light gauge structures, 3D printing technology. So with all that, we can achieve sustainability in concrete. So why new generation concrete? Why you are want to go for special concrete, new generation concrete? Because our main idea is to reduce the carbon footprint. Okay. Then we are now trying to make the concrete easy to flow. It should flow easily, set faster. Okay. Should have a quick strength for the precast elements. Should be self-curing because you don't want to add more water. Should be self-curing. Then net zero cement. There should not be any cement in geopolymer concretes. Then we're going for special concrete, light emitting concrete, okay, transparent concrete, translucent concrete, decorative concretes. Concrete should be bendable concrete, printing concrete should be print. We should be able to print the concrete. So how the technologies in the software are evolving, in the aerospace is evolving. Similar way, in medical field, the science and technology is improving. The concrete technology also, every day there is a evolution. There is a new application, new product development is happening. I would like to take all of you through certain new developments which have taken place. So friends, we know, okay, concrete is a versatile material. It's the man-made material. It takes the shape of the form what we provide to that. We can bend it, we can cast it in any shape, any manner. So the durability is very important. Whatever concrete we make, the concrete system we develop. So materials are very important. First of all, selection of material is very important. What kind of binder material, aggregates we are using, admixtures we are using, what kind of mixed design we are following is very important. When we get the good quality material from a reliable source, which are as per the standards, then the process, the 7 only process in concrete making. One is the mixing, the patching, then transportation, after transportation, placing, compaction, curing, then taking care of the concrete after placing the concrete, covering it based on the ambient temperature. Okay, controlling the temperature is very important, and workmanship is very important. You may make good quality concrete, best concrete using the best of the material. If the man, the person, the mason who is making the concrete, he is not skilled, then we are going to have a very bad concrete. So 50% only lies with selecting the good raw material and making the good concrete, and 50% lies with the manpower, the man who is going to handle. So more and more mechanization is happening now. We're having Maiwan former technology. Then we have got self-compacting concrete, small dynamic concrete. So good places we are having, mechanical mixers we are having. With all that, the dependency on the man is coming down, the errors are coming down. Okay. So this is the first part, the materials and also the making of the concrete. Then the concrete is set. So physically it should be very strong. Okay, should not be a weak concrete. Should be strong enough to withstand abrasion, erosion, okay, freeze thaw actions. These are important. So when it's attacked by chemicals, because when you leave the concrete exposed to the atmosphere, there may be coastal environment, as it may be general applications. So we are going to get concrete associated with moisture, carbonation, sulfates, chlorides, alkali silica reactions. So there are many. These are many things which attack on the concrete and alternate wetting and drying conditions. So the concrete which is designed and made and submitted, compacted, placed, and cured, it should be able to withstand all these chemical attacks on the concrete. So sustainability approach, okay, to make the concrete more sustainable, I've already told you, discussed with you, should have a replacement for cement because it's not an eco-friendly activity. We should use mineral admixtures like fly ash, GGBS, metakaolin, razor's ash, okay, and ultrafine GGBS, ultrafine fly ash. So aggregates should use recycled aggregates and artificial aggregates. Fine aggregate would go for alternative to river sand. Water, using high range water reducing admixtures like PC based admixtures, you can reduce the water requirement for concrete making because we always get scarcity of water. Our idea is to reduce the water demand. Okay, and with all that, we have to improve the durability of the concrete. The durability of the concrete can be achieved by using SCMs, secondary cementitious materials, and which enhances the performance of the concrete, enhances the strength, durability, resistance to chloride, resistance to sulfates. So all these things will be achieved by using SCMs. So these are the different types of SCMs we are having. We are having fly ash. So we know this it comes from thermal process. Thermal power. Yes, also it's off-white in nature. It comes from steel. All these are cementitious materials. These are the byproducts of the porous materials which are having calcium, which are having silica, alumina. We can blend it with the cement and make blended concretes. So coming to the new generation concretes, my dear friends and students, I've already told you self-compacting concrete. Okay, the concrete which compacts on its own, you don't require vibration. It was invented in Japan, okay, because they used to do a lot of developments after the Second World War. Japan was under reconstruction completely. They used to do a lot of night-time concrete and also heavy congested reinforcement. To avoid the sound pollution, they invented self-compacting concrete, which can flow like water. It's having higher cementitious materials. We have smart dynamic concrete and temperature controlled concrete for mass concreting application, raft 2 meter, 3 meters height. Now it's going for very high rise buildings. So in that case, you need to control the temperature. Then fiber reinforced concrete applications, that is very much used for grade on slabs application, flooring applications. Okay. Then we have self-curing concrete. The concrete which cures on its own, does not require water. Then self-healing concrete. Self-healing concrete is one concrete which any cracks develop, it heals on its own, like pectoral concrete. So this is now gaining momentum. Okay, any small cracks which are happening gets bridged. Then colored concrete is one more concrete which finds very architectural applications. Then GFRC, glass fiber reinforced concrete, especially Jolly and other architectural elements they are being made. This is very popular for interior applications. Then we have reactive powder concrete. Reactive powder concrete is one concrete which is having high tensile strength. So the grade of concrete may be M500, M700. So it doesn't require steel at all. Certain structures have been built using this reactive powder concrete. Then we have geopolymer concrete. The concrete is very net zero cement concrete, does not require cement at all. Using slag or fly ash, using certain chemicals, we can develop geopolymer concrete. This is very good. Permeable concrete is one more grade of concrete which allows the water to percolate. Permeable concrete is very popular, especially in making pavements and all, car parking ways. It's very popular in many countries. They make permeable concrete so that water drains below the ground, so you are recharging the groundwater. These are the various types of concretes available. So self-compacting concrete is very popular. You may all be knowing this very popular concrete. We have done a lot of self-compacting concrete. I was working in RNC India earlier. It's very good concrete, especially in the congested reinforcement, where you cannot put a vibrator needle, and the concrete will flow like water. It's very popular. Millions of cubic meter of concrete is being used worldwide. So this requires a finer aggregates, less than like 10 mm and down, and also we need to have a air powder content up to 500, 600 kg. Cement GGBS or cement fly ash or lime powder will be added. This self-compacting concrete. So I've already told you this was invented by Wakamura, Professor H. Wakamura. He was from Japan. So during the 1980s, they invented this self-compacting concrete, and it overcame the requirement of skilled manpower, and placing of the concrete was very easy. Okay. Advantages are many. Advantage, better process and faster completion of the project since placement, better quality in terms of better surface finish, enhanced durability, and also self working environment due to trouble-free placement of concrete. Environmental friendly with reduced in noise pollutions. Better moldability, you can mold the concrete in an easy way. So more economical with reduction in time, manpower, and the resources for concrete placement. Better reinforcement bonding. These are the many advantages of self-compacting concrete. Applications. So this concrete can be applied for RCC members where the congestion reinforcement is there, flooring application, machine foundations, okay, tunnels, high-rise buildings, retaining walls, raft foundations, and pile foundations. So Bangalore itself, many projects they are using this self-compacting concrete, high-rise buildings and all. We should visit many sites and all to learn from how it is being done. Some of the buildings, SEC, you can look at the finish, beautiful finish, how the concrete has been made, how the finish is there. You don't even see a small cracks or small potholes or honeycombing here. It's come out very good. Okay. One more grade of concrete is smart dynamic concrete. Smart dynamic concrete, which uses lesser cement content, up to 450 kg, 400 kg. You can make a smart dynamic concrete. So this was invented by a company called BASF. It is a trademark of BASF. So you can design M25 to M35 grade concretes using a smart dynamic concrete. It uses its own recipe of admixtures, glinium-based admixtures, VMA-based admixtures, which helps to make the concrete very cohesive in spite of lesser cementitious materials. So many projects are using. Where they use smart dynamic concrete, 34 floors, flowable concrete. This is the construction they have done using smart dynamic concrete. We supplied GGBS there, and we have done a lot of study. You can see the flow of the concrete. And also, we have studied compressive strength from starting from 7 days to 181 days. The M50 grade concrete, it has developed 78 MPa, almost 30 MPa more than the required strength, M50 grade concrete. So when we use material like GGBS, the strength enhancement is much larger during the later age strength. So it will give you a compressive strength, minimum compressive strength on 28 days. But as the concrete ages 90 days, 181 days, the strength improvement is much larger. This is a laboratory results I have taken from laboratory only. You can see how M25 grade concrete, which 50% GGBS, it has gone up to 56 MPa. Almost the strength has double. Okay, 110% improvement is there in the strength. This is the building. We took the photographs at the different stages. Once it's finished, you can see how beautifully the building has come out. Very good. Recently, I think this mall was also opened. Global Mall was opened. one of the largest mall in Bangalore. So this is done with smart dynamic concrete. So coming to the temperature controlled concrete, as I already told you, this is concrete. Use it for mass concrete applications, um, especially massive foundations, mass concreting for dams, hydroelectric projects, high-rise buildings. Okay, the advantages are many. Reduce plastic shrinkage cracks in fresh concrete because of the rising temperatures up to 70, 80 degree, 90 degrees centigrade, because of the huge mass of concrete you are pouring. So there will be a lot of shrinkage cracks happening, then concrete will become weak. So the temperature controlled concrete, will be using ice flakes to bring down the temperature. We'll be using cementitious material like GGBS up to 65 to 70%. One more example, this building Lodha Towers in Mumbai. This is one of the tallest building built in India. They've used concrete building GGBS. You look at the cement content. Cement content is 150 kg, GGBS is 350 kg out of 500 kg. So using mineral admixtures, which not only bring down the carbon footprint, but also helps in designing many new concrete. 70% GGBS was used. The 56 day strength specification they have given. Since it's a mass concreting applications, they have not given 28 days compressive strength. They have designed the concrete for 56 days because you are using higher replacement of GGBS. This is the building foundation which was built. Then blended concretes. In all the RMC plants in Bangalore, anywhere you go, they go for blending. They buy OPC cement in one silo. You will be seeing some 3 to 4 tall silos. So they store the material, fly ash, GGBS, silica, metakaolin, cement. So when they make the concrete, they expect the computer application. They type it 30%, 40%, 50%. That material will be coming together along with cement, mixed, and concrete is made. These cementitious materials are very useful, not only to bring down the cost of concrete, and also durability is enhanced. So one of the examples, case study, we have done with fly ash and GGBS mixes. You can look at the strength, 7 days, 28 days compressive strength of M20 to M50 grade concrete. We have studied so the GGBS having cementitious content more, calcium oxide 40%, gives a little bit more superior compressive strength compared to the your fly ash mixes. This is the graph, fly ash graph and GGBS graph. You can see the GGBS product which giving better strength compared to fly ash concrete. Based on the replacement levels of GGBS and fly ash, you can save the carbon footprint. Pure OPC mix M30 grade concrete, the carbon dioxide emissions 370 kgs per cubic meter. When you use GGBS 70%, it has come down to 139, about 140. So, okay, almost reduction is there, huge reductions, more than 60%. Similar way, we have done a study using GGBS for the last 5 years, how much the carbon dioxide reductions we can do. We have done saving of 5.97 million metric ton of OPC. Carbon dioxide reduction is about 5.24 million tons. We have conserved the limestone up to 8.36 million tons, like that. Okay. Also, the product is certified by IGBC, Green Building Council, for sustainability. Similar way, if you are making concrete using GGBS up to 40%, you can save carbon dioxide emission by 105 kg per cubic meter. So in that calculations, I have done a working for various quantities of ready-mix concrete. So for doing 10,000 cubic meter, we can save 1050 trees. Why I'm telling trees? I'm taking one tree can absorb 22 kg carbon dioxide in a year. In its lifetime, you can absorb 1 ton carbon dioxide. One tree, what you grow, can absorb 1 ton of carbon dioxide. So taking that into calculations, I have done the analysis. So if you are doing a big project of 2 lakh cubic meter concrete, you can save up to 21,000 trees. That is the saving. So how to, if you want to really plant 21,000 trees, is very, very difficult. You can't even grow one tree in front of your house. So so much difficulty is there. Okay. So think about 21,000 trees. So entire concrete production, if you take, we are making about 60, 70 million cubic meter. I'm giving South India. South India, we average about 30 million cubic meter of concrete. So using GGBS, we can save 4 million trees per year. 4 million trees, you can create one more forest. That is the advantage of using GGBS. Similar way, we have compiled data for many companies. So you can use 60%. This is a blended concrete. This is what I have done: 60% GGBS, 40% cement. You can see the improvement in the compressive strength compared to OPC mixes. It gave on 90 days 34.23 MPa. The GGBS mix with 60% GGBS has given 36.77 MPa. So not only saving cost, but also durability, performance enhancement, longer strength. Similar way, we have done for the M25 grade concrete. You can see a clear upper graph. So with the improved compressive strength compared to the pure OPC mixes. Similar way, M30 grade concrete. All the grades of concrete have been tested. It's not only 3 cube, 6 cube. It is more than 200 cubes we have done. And we have done the analysis. With the higher replacement of GGBS, we are going to get more and more better strength. So durability of concrete with slag or fly ash is very good because it will have a perfect particle packing, reduction in the chloride intrusion, improving corrosion resistance, reduced sulfate attack, reduced alkali silica reaction. So overall, it will improve the durability of the concrete. So coming to the next grade of concrete, fiber reinforced concrete, where we induce fibers. Earlier I was working in Reliance, we used to market fibers for concrete applications. So these fibers are very good, especially grade on slab applications, where you want to improve the toughness of the floor, improve abrasion resistance, improve impact resistance, and concrete roads. They are very useful to improve the properties of the concrete. So advantages are many. It will reduction in shrinkage cracks, makes the mix cohesive and homogenic, reduced bleeding, improved flexural strength. Okay. Applications are many. We use this FRC for high grades of concrete, grade on slabs, deck slabs, and many applications. We use airport taxiway, hangars, concrete roads, precast girders. So where we require flexural strength, want to replace reinforcement for grade on slabs, you can use steel fibers and make the concrete floor without steel. So that way, FRC applications are wide and accepted everywhere globally. So coming to the architectural concrete, we have many types of concrete: colored concrete, stamped concrete. So this is one, the Infosys, where I was working in RMC India, Infosys Mysore. We used pigment to create a pathway in the concrete because they wanted the eco-friendly solutions. This is one we have done using pigment. The concrete was made in Infosys Mysore. Similar way, these are the many stamped concrete applications which is gaining acceptance. The pathways, the parking lots, the sit-out areas and all, and garages. They are all using this different types of designs. Then high density concrete. High density concrete is used for nuclear reactors and all. So they're also using sustainable approach. Today morning I had a presentation for Bhabha Atomic Research Institute, Mumbai. So they wanted to adopt sustainable. Earlier they were using for pure OPC concrete. So after my presentations, they have agreed to use blended cement like slag cement, GGBS, the concrete making. Okay. So everybody is accepting now because once you apprise them regarding the advantages, benefits, how it is going to help concrete, they are going to use these sustainable materials to bring down the CO2 emissions. Like I already told you, foam concrete, lightweight concrete. So many types of concretes are available, which are used for filling purpose. Let us say you want to fill up some embankment and all. Lightweight foam concrete can be used. Permeable concrete is one, as I've already told you, especially use it for water seeping purpose, and especially walkways, driveways and all, where you want to recharge the groundwater. The permeable concretes are very much in demand. And abroad, many places they do these permeable concretes. India also gaining acceptance. Yeah. And coming to lightweight concrete, where you want to reduce the structural weight on the existing buildings, you want to go for one floor more, two floor more. Because in cities now, what's happening? they are giving a higher FAR, floor area ratio, because of the metro coming and city landscape changing. So when that happens, already you constructed a 5-story building. Want to add another 3 floors? Not possible. You can add only 1 floor. So by using lightweight materials, you can construct 3 floors, so you can increase the revenue of the customer. If you rent it out to the customers or anybody, you'll get additional revenue. So like that, now light structural concrete, lightweight structural concrete is gaining acceptance. Decorative concretes is one more type of concrete used for decorative purpose. So many things, many builders are now adopting decorative concretes. Concrete is getting polished. This is at BMS College of Engineering, where we did the Deminar. So I was there. I was the secretary. Dr. R.V. Ranganas was the chairman. At that time, we had decorative concretes. Okay, as a Deminar topic. So we made concrete polished. I supplied concrete from RMC India. This was the floor. By polishing it, it looks like a granite floor. Same concrete. We got after polishing using certain chemicals. The concrete floor was prepared. So polished concrete. It is gaining acceptance everywhere now. Similarly, exposed aggregate concrete to give a variety to the concrete. Then geopolymer concrete, I've already told you, very popular in Australia. And India also is getting acceptance. Recently, a new IS code has been issued with precast geopolymer concrete, and all. It's very good concrete, very helpful. Okay, and also especially you want quicker strength and we want to open the road for traffic next day or next 2 days. This is very useful, especially this concrete is resistant to acids, especially if you want to do concreting for sewage treatment plants. Sewage liners, stormwater drains and all, we should go for geopolymer concrete applications. So that one more concrete, reactive powder concrete is very popular, and you get a very high compressive strength. You use different materials for this reactive powder concrete. The properties are very high, higher than 200 MPa strength, can be up to 810 MPa. This is one of the bridge which has been built somewhere in Canada. One is in Canada and one is in Europe, actually, I believe, using the reactive powder concrete, where they have removed steel completely. Without steel, they have built. When you are getting such a good compressive strength, why can't you use it? Because they use steel fibers there. Very low water cement ratio. And also, look at the material combination for the reactive powder concrete. We have cement, we have silica fume, we have quartz sand, we have water, we have special admixtures. This is special admixture. 2 types of special admixtures we are having. So these are some of the structures they have built using reactive powder concrete. 6 meter span pre-stressed pedestrian bridge in Sherbrooke, Canada. 200 MPa compressive strength was there. Like that, Seoul, Sakata Mirai pedestrian bridge in Japan. The Seoul Seno footbridge in Seoul. So like that, people have tried many experimentations. So coming to the last topic, backroll concrete, which are healing, self-healing concrete. As I told you in the initial presentations, using bacteria, inducing bacteria, we can make concrete. A lot of people are doing research work in India also on this product. Soil Bactrum, commonly called Bacillus pasteurii, was used in backroll concrete. Advantages are many, especially alkali sulfate attack resistance is there, freeze thaw resistance is there, plastic shrinkage cracks reduced, and strength increased 5 to 10% compared to ordinary concrete. Because any cracks development, it will make the concrete to heal on its own for a period of time. Then coming to the ultra thin white topping concrete, which is becoming very popular nowadays in Bangalore, where we are laying the concrete roads on the bituminous roads. So thickness 100 mm, high early flexural strength, low permeable, self-compacted concrete, curing 7 to 14 days. These are the basic properties of ultra thin white topping concrete, gaining acceptance everywhere. And so in the mass housing projects also, this technology is being adopted. Self-compacting concrete, smart dynamic concrete. We are building Rajiv Gandhi Housing Corporation, Prime Minister Awas Yojana. In all the places we are using Maiwan Formwork technology and constructing this. We can't call it as low-cost housing, mass housing project for the lower income group, middle income group, like that. Then one more type of construction is light gauge construction, sandwiched panels and all, where the concrete usage is very less. So these are the various types of light gauge construction using steel and cement and concrete, composite construction, superior quality, faster construction. So this is affordable housing, getting acceptance in city like Bangalore, Mysore, Chennai. Finish is very good. They are using Maiwan Formwork technology here. Then the final innovations are happening in the 3D printing technology, is getting acceptance. This first building built by IIT Madras. Recently it has been done. This is concrete getting printed. See, how you print your this thing, photos or anything similar way, using sustainable materials, thin structures are being built. Wall thickness is very small, and they provide accommodation and this thing. You can use very innovative solutions, materials here. So, the summary, I would like to give presentation on how we can make better quality concrete, sustainable concrete, durable concrete, and also eco-friendly concrete, special concretes. So, in each and everything, we have to look into that physical properties, workability, material science, durability, okay, resistance to chemical attacks. These are all the important things. So concrete should perform its duty in the fresh state, hardened state, and also should be long lasting. So keeping all this picture into mind, we can design many varieties of concretes. We already discussed all the varieties. They are very good concretes actually. So I would like to conclude with my presentation. Special concretes are the need of the hour. Special concretes, decorative concretes, high performance concrete, high strength concrete. So using industrial byproduct like fly ash, GGBS, and other alternative materials is the need of the hour. Using alternative technology, we can reduce the carbon footprint. We should make it economical, sustainable, and durable. So continuous research work is the need of the hour to evolve new technology, new methods in producing eco-friendly concretes, sustainable concretes, and durable concretes. With that, I would like to close my presentation. I thank Atrium Institute of Technology for providing this wonderful opportunity to me to share the presentation. Thank you. It's over to the organizers.
Thank you, sir. So, few questions are there in the chat box. I will just read out. Question from Anusha M, professor from Civil Department.
Yeah.
Geopolymer concrete has incorporated in structural elements. Why can't we do the complete building construction using geopolymer concrete?
Yeah, geopolymer concrete. Now, new code has come to manufacture precast segments. Okay. So it's still in the laboratory stage, and many people are trying to evolve. So far, making geopolymer ready-mix concrete is not evolved in India. Only code has come for making precast segments, because we have to make the concrete to flow. The geopolymer concrete is more sticky. So only in Dubai they have done self-compacting geopolymer concrete. There they have evolved. I feel in the next 5 to 10 years down the line, in India also we start using that. So the company should come forward to make this concrete available. The new codes have to come. Now they have allowed precast segments. So we can use precast segments made out of geopolymer concrete to construct any houses. There's no problem. Especially making ready-mix concrete, so far the codes have not been evolved to make geopolymer concrete.
Thank you, sir. So, one more question from Anusha madam. Geopolymer concrete is not economical due to the material and solution used for polymerization process. How can we project this geopolymer concrete in low-cost housing technique?
Nowadays, what's happening, like geopolymer concrete is a high-grade concrete. M50, M60 will strength is given. Well, if you want to make M50, M60 grade concrete with the regular material, it's costing so much. Between geopolymer and regular concrete, when you look at high grade, lower grade, I know, lower grade the regular concretes are cheaper compared to geopolymer. You go for high grade concrete. Geopolymers are almost same, coming same has regular concretes. Maybe 6,000, 7,000 rupees per ton is the cost of the concrete. So people are evolving technology. We have to make the chemicals cheaper because your fly ash, your aggregates, your GGBS is cheaper compared to the cement, what we use for normal concrete. So the chemicals are a bit costly. If you can bring down the chemicals cost, in that direction also a lot of Indian companies are coming forward to manufacture these chemicals so that it comes in on par with the regular concrete.
Participants, if you have any questions, you can unmute yourself and you can ask, or you can put it in the chat box. Sir, one more question is there from Ansha Madam. Please share the method of guidelines, that is IS code, for geopolymer concrete.
Sure, I'll share the guidelines. No problem. Let him share this thing, email ID to me, I'll forward it to them.
Okay, sir.
Thank you so much. Thank you.
Thank you so much, sir, for spending your valuable time with us and sharing your knowledge. Now I request Dr.
I request
Surendra
my
HJ
video to be sent to me. I will upload in the YouTube. I request my presentation video to be sent to me. Okay.
Yes, sir, sure. So now I request Dr. Surendra HJ to give a vote of thanks.
Thank you, madam. So it is my immense pleasure to propose a vote of thanks to the eminent personality, Dr. Manjunath sir. When I approached sir, he accepted immediately. Surendra, I will do like that. So sir is always supportive to us, to all our activities. Thank you very much, sir. In spite of your busy schedule, you accepted our invitations and delivered a splendid presentation. On behalf of Department of Civil Engineering, Atria Institute of Technology, we express your sincere gratitude to you, sir. Thank you very much, sir.
Thank you, Mitch. Thank you very much, Dr. Surendra, sir. Thank you so much.
So I thank head of the department, Dr. Uday Sima sir, coordinator, Pratima madam, Karthik sir, all the faculty member and my dear students for attending these sessions. Thank you very much. We'll meet you tomorrow at the same times with the different speakers. Okay. Thank you all. Have a good day.
Thank you, sir.
Thank you.
Participants, feedback link is shared in the chat box. Kindly give your feedbacks.